Here we have another logarithmic differentiation example problem, and we want to differentiate g of w, which is equal to 3w minus 7 raised to the 4wth power. So when we evaluate this right-hand side, it looks a little bit complicated. We have a variable that's in our exponent, and so one of the techniques that we can use is natural logarithms to ultimately simplify our expression and then take the derivative. So that is what we'll do. We'll take the natural logarithm of both the left-hand side and the right-hand side, and then we'll use our properties of logarithms to expand this right-hand side. And we know that one of our properties is that we can move the exponent out in front. So we have this 4w multiplied by ln of 3w minus 7. And so now that we have everything simplified and rewritten, we can go ahead and use implicit differentiation to take the derivative. So here we have d dx of ln of g of w, which is going to be equal to d dx of 4w ln of 3w minus 7. And when we look at this term on the right, we know that this is a product rule since we have a function which is multiplied by another function. And so we can go ahead and start our derivative process. We know that on the left-hand side, we'll get g prime of w divided by g of w. And on the right-hand side, we'll get the expression shown here by taking the derivative of the first and second term, which is similar, or which we'll use in our product rule. The final step is we can go ahead and simplify our right-hand side and then factor in our g of w. So now we have our g prime of w written in terms of g of w. And we can go ahead and then back substitute our g of w term, and that will give us our solution for our example problem.